Okay, so welcome back. The purpose of this video is going to be to go over the first page of your Riemann sums notes. One more time, Riemann sums is basically a method that allows you to approximate the area under the curve by adding the areas of rectangles. So in this video, we're going to take the area under a curve and we're going to approximate it by drawing rectangles under the curve and adding the areas of those rectangles together. And adding the areas of those rectangles. And there's going to be 3 ways that we're going to do this. The 3 basic methods we're going to do this are going to be either a left Riemann sum, a right Riemann sum, or a midpoint Riemann sum, and you will see these as L sub n. N is going to represent the number of rectangles that we are going to be using, and this is usually provided. They tell you how many you draw. So let's get started. We are going to take a look at the function 9 minus x squared on the interval 0 to 3. And we are being asked to draw 6 rectangles of equal width. This is important. The width of each rectangle is going to be called delta x. Delta x is simply the change in x for each rectangle. So that would always be computed as the difference of the interval divided by the number of rectangles. So the general formula would be b minus a, and b and a, of course, are the endpoints that we're going. In this case, a would be 0, b would be 3. So we're going to take b minus a, and then we're going to divide it by n, n being the number of rectangles. So number of rectangles. Okay? So in this particular example, we are going from 0 to 3, and we are going to be dividing that by 6. So our delta x for this example will simply be 3 minus 0 divided by 6, which you will note reduces to 1/2. So that means each rectangle is going to be 1/2 wide. Okay, that's our width. Now in this particular example where we have our picture already set, 9 minus x squared is a parabola facing down, shifted 9 units up, and we're going to be drawing 6 rectangles. First thing is, because of the way the graph is given, students often think these are units of 1. But that's not true. If you graph this on your calculator, you will see that this intercept is actually 3. So let me make sure that we write that there. This is actually 3. So what you're going to notice then is that these are actually increments of 1/2. So this would be 1. Sorry, let me redo that. That's actually 1.5. This would be 1 right here. And this would be 2, and then you have 3. Now we're drawing 6 rectangles, not 3, so that means each rectangle is going to have a width of 1/2. Now pay attention to how this is going to get drawn. Our first rectangle is going to start from 0, and it's going to go over to 1/2, because that's the width. Okay, so that's our first one. It's going to start at 0, and it's going to go over to 1/2. So this is the coordinate 0, this is the coordinate 1/2. Because it's a left Riemann sum, we are going to use the left endpoint, which is 0, to draw the height of the rectangle. So the height of the rectangle is basically going to be the y value of the function at 0. And if you were to evaluate that and plug 0 in for x, you would see that the height is 9. So this here is 9. What we'll do is we'll simply draw. It's going to be a little hard for me to draw this the way I have my tablet, but I'll do my best. I'm going to simply draw a line straight up until you hit the function. Once you hit the function at 9, you extend over. You extend over to 1/2. So a little higher right here. And you draw the rectangle down. Okay. Okay, so I think I found a better way to do this. The pencil was giving me a hard time. So I'm just drawing lines. So let me move this over here. Move this over here. So the width is 1/2, as we stated earlier. And I just go all the way till I touch my function. In that case, it's actually 9. And what I'll do, keeps moving it. Maybe it's not gonna work. Maybe I'll just have to do it with the pen. I just draw across, and then that creates, it's supposed to be 9 coming down. This is really hard with this tablet. This area here, okay, that's 1, 2, and so again we're going from 0 to 1/2. Okay, the next, so you can color this in if you have a highlighter or something nice to color it in, you can. The next rectangle is going to go from 1/2 to 1. Again, the width is 1/2. So instead of, my choices are between 1/2 and 1. I'm going to use the left end point, so I'm going to go up until I hit the function, and then across. It shouldn't go on the function, it should be directly across. So you can tell right now that I'm going to get a bit of overflow here. So this is going to be an actual overestimate. I'm trying real hard to make my line straight. And you get another rectangle. The third one goes from 1 to 1.5. Because we're going with the left end point, of course, we would go from 1 all the way till we hit the y value on the function. Go across and then come down. That gives us another one. Then from 1/2 to 2, we use 1/2. Go up, go across and down, color it in. Then from 2 to 2.5 here, we go again to the function on the left end point, go across and down. Good. And the last one, we're going to go to 2.5 to the function over and down. Now, clearly this is an overestimate. So whatever answer we get, this is going to be more than the true area. We can see that already, but that's okay. For you, what I'd like you to do is fill this area here, and I'm not going to finish it. I'm going to do the first few, and then you're going to complete it and write a total area for our discussion tomorrow. This x1 basically means, hey, what x value did you use for the first rectangle? Because we're choosing between 0 and 1/2, we chose to use 0, and the sub 1 just means first rectangle. In the first rectangle, we let x equal 0, and so if we plug that 0 into our function, 9 minus x squared, we got 9. Okay? Now, I should really add another column here, calling it delta x. Oftentimes students think you multiply 0 times 9, and you don't. X equals 0 is the value you plug into the function to get your y. Your y is your height. In this case, this rectangle is 9 units high, but it's still only a half a unit wide, so 0.5. Therefore, the area of this rectangle will simply be 9 times 0.5, which of course is 4.5. Okay, and you can do these with calculators, no problem. This one you could do by clearly in your head, but it's no problem if you use a calculator. Let's do the second one. The second rectangle is between 1/2 and 1. So what did I choose? I chose 1/2. Okay, and if I plug that into this function, I will get 9 minus 1/4. 9 minus 1/4 is 8.75. Delta x is still 0.5, so we're going to multiply the delta x, which is the width, okay, of the rectangle, by the height. And in this case, we're going to get 4.375. Okay, I'll do just one more and then you can complete the rest. The third rectangle, I choose between 1 and 1.5, so of course I'm going to choose 1. If you can see, these are increasing by a half, which is exactly what our delta x is. Plugging 1 into the function, of course, gives us 8. And we multiply 8 times 0.5, which is the width of the rectangle, and that gives us 4. And you're going to follow along until you get all of the areas of each rectangle. At the end, you're going to add all those areas together, and whatever number you get, that is going to be your total area. Now remember, we know already that's going to be an overestimate, but that's okay. It's just an estimation. All right, on to left rectangle. Okay, so on to right rectangle. The R means we're going to use a right rectangle approximation with 6 rectangles. The good news is the delta x is still the same because we're going from 0 to 3, so that will be 3 minus 0 divided by 6. which of course is a half. So our intervals here, this is 3 still. Everything is increasing by a half. So you have a half, 1, 1 and 1/2, 2, 2 and 1/2, and 3. Okay, our x's are gonna vary though. That's gonna change now, because you see our first rectangle is gonna go from 0 to 1 to 1/2. So our choices here are gonna be between 0 and a half. Because we're going to the right now, instead of using the left endpoint, we're gonna use the right, which means you're gonna go to 1/2 and you're gonna make your way up to the function. And then as soon as you hit the function, this should be less than 9. Okay, the other one was 9, slightly less than 9. That creates a rectangle. On the on the next one, the second rectangle, your choices are between a half and 1. Because it's a right rectangle approximation, we use the right. Going up and over and coloring it. Okay, one more. Between 1 and 1.5, we're of course going to go with the one on the right, which is a half. So you go all the way till you hit the function, and then just straight across. And that's the third one. Okay, so you get the idea. You can finish that, but I just kind of want to show you what that means for our table now. For x1, instead of choosing 0, I'm now going to choose a half. And my y is going to be based on that 1/2. So remember, the function is 9 minus x squared. So I now need to plug 1/2 into here to get my value. You're going to notice it's the same value as above, except it's shifted. Instead of 9, we're going to start with 8.75. Okay, so these values are going to repeat themselves because you're still using the same endpoints, but it's shifted to the right. Instead of starting at 0, you start at a half. In the area for this, again, you're multiplying this 8.5 is going to get multiplied times the delta x, because that's the width, and so you end up getting 4.375. Okay, I'll do one more just to make sure you got it. Between 1/2 and 1, we're going to go with the right, so that means we're using 1. You'll notice our increment here is by a half, and the y value is exactly whatever the function value is at 1. So if you plug in a 1, you're going to get 8. And 8 gets multiplied by a half, and you get 1/2 for that. You're going to continue this process, and then you're going to add all those together, and whatever you get, that's going to be your total area. Something different though, you're going to notice that these are actually underestimates. So there's a little bit of area that we haven't covered, and that's okay. Again, it's an estimate. All right, in the next section, we'll do the midpoint rule. Okay, so for the midpoint rule, we're still going to be using 6 rectangles. Our delta x is still 3 minus 0 divided by 6, which is a half. So the width of our rectangles is still going to be a half. So remember, this is 3, this is a half, this is 1, this is 1.5, this is 2, and this is 2.5. So the width of the rectangles is still the same. Each rectangle is still going to be a half unit wide, and we have the same number of rectangles. The difference is now that instead of using a left endpoint or a right endpoint, we actually got to go to the middle. Okay, so we're going to go to the middle between 0 and 1/2. What is the middle of 0.5? Well, that's a fourth. So for x1, we're going to be using a fourth. Okay, so a fourth. Now don't draw a line, because you're going to get confused with the number of rectangles. Simply put your pencil in the middle, lift it, and then draw a line, an imaginary line, all the way up down the middle. And right there, that y value, that corresponds to 1/4, that determines your height. Now you can draw your rectangle. Make sure you do not draw a line as you're going up, because if you do, you're going to get confused and think you have more rectangles than you do. Your rectangle should still be going from 0 to a half, but the difference is the height is no longer determined by a half or by 0, it's determined by a fourth, which is right in the middle. So the y value is going to be, again, our function is 9 minus x squared. So the y is going to be determined by 9 minus 1/4 squared. And in this case, I did this with the calculator, 8.9375, I believe. Okay, you can double check my calculations on that. So that's your height. Again, it's based off 1/4, which is the midpoint between 0 and 1/2. Now you're going to multiply this by delta x, which is 0.5, and your area should be, or at least I have 4.6 4.46875, I believe. Okay, we'll do one more just to make sure we're good. So feel free to use a highlighter to highlight these in. They look prettier that way. Between 1/2 and 1, the middle of that is 3/4. So the next point we're going to use is 3/4. Notice that 1/4 and 3/4 are exactly 1/2 unit away. So we are actually increasing by 0.5. Now, we're not going to choose 1/2. We're not going to choose 1. We're going to choose 3/4, which is right in the middle. We're going to draw an imaginary line up. Once we get to the curve, we draw our rectangle that height, making sure you're still going from 1/2 to 1. But again, the height is now determined by that 3/4. If we plug in 3/4, it's going to be 9 minus 9 over 16, which my calculator says is 8.4375. And then of course you multiply this y value by the width of the rectangle, which is still 0.5. It's not a fourth. It's still 0.5 units wide. You're just using the middle value to compute the height of each rectangle. Multiply by the width and then compute your area. I believe it is 4.21875. And at the end you're going to add your area, and of course that's your total area. I'm going to ask you tomorrow to think about which 3 of these gives you the best approximation, but that's going to be kind of obvious once you complete all the answers. And then I'm going to ask you to guess what you think the real answer is. Okay, that's it. Hope you get a lot from this video, and hope we can continue the discussion tomorrow. See ya.